The bombs hit the targets. Satellites confirmed the destruction. But the one thing the war was meant to destroy was already gone. In June of 2025, a series of explosions shook the mountains of central Iran. Deep underground facilities that had been watched by satellites for years were suddenly struck by some of the most powerful conventional weapons ever built. American B-2 stealth bombers crossed thousands of kilometers of airspace in carefully planned missions. Their targets were not cities or military bases. They were places hidden inside mountains, places that had become symbols of one of the world's longest nuclear disputes. Facilities like Natanz and Fordow had been at the center of global tension for more than 2 decades. For years, international inspectors from the International Atomic Energy Agency, often called the IAEA, had monitored these locations. Their reports showed that Iran had been enriching uranium to levels far beyond what is needed for civilian nuclear energy. Uranium enrichment is a complex industrial process. Natural uranium contains only a tiny amount of the isotope needed for nuclear reactions. To make it useful, the material must be processed inside machines called centrifuges, which spin uranium gas at extremely high speeds. For power plants, uranium usually needs to be enriched to around 3 to 5%. But when enrichment levels reach 60%, the material moves much closer to what experts call weapons-grade uranium, which is around 90%. By early 2025, international reports indicated that Iran had accumulated hundreds of kilograms of uranium enriched to around 60%. According to nuclear analysts, that amount of material could potentially be converted into several nuclear weapons if it were further enriched. For many policymakers in Washington and several allied countries, this stockpile represented a serious strategic threat. The fear was not only about the weapons themselves, it was about what those weapons could mean for the balance of power in the Middle East. If Iran successfully developed nuclear weapons, other countries in the region might feel pressured to develop their own. This possibility, known as nuclear proliferation, has long been one of the greatest concerns in global security policy. Because of this, American military planners had spent years studying Iran's nuclear infrastructure. They knew that many of Iran's most sensitive facilities were not built on the surface. Instead, they were buried deep underground. Some were carved directly into mountains. This made them extremely difficult to destroy using conventional weapons. To solve this problem, the United States developed a specialized bomb known as the GBU-57 Massive Ordnance Penetrator. Unlike ordinary bombs, which explode on the surface, this weapon is designed to burrow deep into the ground before detonating. Weighing more than 30,000 pounds, the bomb was built specifically to destroy hardened underground targets. For more than a decade, American defense agencies studied the geometry, rock density, and structural design of Iranian nuclear facilities. Military planners simulated potential strike scenarios again and again. They calculated how many bombs would be required, which flight paths bombers should take, and how the facilities might respond to direct impact. By 2025, the plan was ready. When the strikes finally happened, the results appeared dramatic. Satellite images released after the attack showed massive craters above key nuclear sites. The entrances to underground facilities appeared damaged or blocked. Structures that once supported large enrichment operations were heavily destroyed. For a brief moment, it seemed as if the operation had achieved its goal. Political leaders in Washington declared that Iran's nuclear program had been severely crippled. Some officials even suggested that the program had been effectively eliminated, but inside intelligence briefings, analysts began asking a different question, a question that quickly became far more important than the craters visible from space. The facilities had been struck. But what about the uranium itself? Enrichment facilities are complicated machines. Centrifuges can be destroyed, buildings can collapse, but the uranium that flows through those machines is different. It is a physical material. It can be moved. And according to earlier international inspections, Iran's most valuable nuclear asset was not the buildings or the centrifuges. It was the stockpile of enriched uranium. Roughly 400 kilograms of highly enriched material had been recorded in international reports before the strikes. If that material had been inside the targeted facilities when the bombs hit, it might have been buried under thousands of tons of debris. But if it had been moved beforehand, the entire strategic picture would change. Within days of the strikes, intelligence agencies began examining satellite images again. They reviewed shipping activity. They analyzed vehicle movements near nuclear facilities in the weeks before the attack. Slowly, a troubling possibility began to emerge. Some analysts believed the uranium had been relocated before the bombing campaign even began. If that was true, the operation had destroyed buildings and equipment. But the most important element of the nuclear program might still exist somewhere else, hidden, unaccounted for, and possibly deeper underground than any weapon could reach. That possibility turned what had seemed like a decisive military success into a far more complicated mystery. Because if the uranium was no longer inside the facilities that had been bombed, then somewhere, in a location still unknown to American intelligence, Iran's most valuable nuclear material might still be waiting. For decades, intelligence agencies around the world had watched Iran's nuclear program closely. Satellites passed over Iranian territory every day. Signals were intercepted. Supply chains were studied. Scientists were tracked. Every shipment of specialized equipment was examined. From the outside, it appeared that the world's most advanced intelligence networks had a clear picture of what Iran was doing. But intelligence is rarely perfect, and sometimes the most important events happen quietly, long before anyone realizes their significance. In the months leading up to the strikes in 2025, Iran had already begun preparing for a scenario that many governments believed was inevitable: an American military attack on its nuclear facilities. Iranian officials had listened carefully to public statements from Western governments. They had watched military exercises in the region. They had studied satellite surveillance patterns. From their perspective, the warning signs were clear. The question was not if an attack would come. The question was when. And so, inside Iran's nuclear infrastructure, certain preparations began to take place. None of them were dramatic. There were no large convoys that satellites could easily track, no major public announcements, no obvious emergency evacuations. Instead, the preparations were slow and deliberate. One of the most important details about enriched uranium is something that many people do not immediately realize. Unlike nuclear reactors or centrifuge facilities, uranium itself is not enormous. When converted into uranium hexafluoride gas and stored properly, large quantities can be contained in metal cylinders that are not much larger than industrial storage tanks. In practical terms, hundreds of kilograms of enriched uranium can be transported in containers small enough to be moved by trucks. That portability creates a major challenge for intelligence agencies. A facility can be monitored from space. A moving container cannot always be tracked so easily, especially if the movement takes place inside a country that already operates under strict internal security controls. By early 2025, some Western analysts had begun to suspect that Iran might relocate its most valuable nuclear materials if it expected a strike. But predicting where that material might go was far more difficult. Iran is a large country. Its territory covers more than 1.6 million square kilometers. Much of it consists of mountains, deserts, and sparsely populated regions. For decades, Iranian military planners had designed underground infrastructure precisely to take advantage of this geography. Facilities were hidden beneath hillsides. Missile storage bunkers were buried inside mountain ridges. Entire military complexes were built underground to protect them from air attacks. This strategy was not unique to Iran. During the Cold War, both the United States and the Soviet Union built deeply buried facilities to protect strategic weapons, but Iran had taken the concept even further. Instead of concentrating everything in one location, Iranian planners distributed sensitive infrastructure across multiple sites. Some locations were well known, others remained deliberately ambiguous. When the bombing campaign began in June 2025, American intelligence analysts expected that most of Iran's enriched uranium would still be located at known enrichment facilities. After all, those were the places where international inspectors had last recorded the stockpiles. But intelligence assessments depend heavily on the timing of information. The last confirmed inspection reports were weeks old, and in a fast-moving geopolitical crisis, weeks can be enough time for major changes. When the bombs fell, they destroyed centrifuges and damaged underground chambers, but the explosions could not answer one crucial question. Was the uranium still there when the bombs arrived? In the days after the strike, intelligence agencies began conducting what is known as post-strike damage assessment. This process involves analyzing satellite images, intercepted communications, and other intelligence sources to determine what was actually destroyed. At first, the images seemed promising. Entrances to underground tunnels appeared collapsed. Surface infrastructure was heavily damaged. But the deeper analysts looked, the more uncertainty appeared. There were no clear signs of radioactive contamination that might indicate large quantities of uranium had been destroyed. Transport routes near the facilities showed unusual vehicle movements in the weeks before the strikes. And inside classified intelligence briefings, analysts began presenting a troubling possibility. Iran may have moved the enriched uranium before the attack began. If that assessment was correct, the bombing campaign had achieved only part of its objective. Yes, centrifuges had been damaged. Yes, enrichment facilities had been disrupted. But the most valuable component of the nuclear program, the enriched uranium itself, might now be somewhere else entirely. Hidden, protected, and possibly located in a place that military planners had not originally targeted. As intelligence agencies expanded their search, attention gradually shifted toward one particular geographic feature that dominates much of Iran's landscape: a vast mountain system stretching across the country. A place where tunnels can disappear into rock, where underground facilities can be carved hundreds of meters below the surface. A place where even the most powerful bunker-buster bomb might struggle to reach. The Zagros Mountains. And somewhere within those mountains, analysts suspected the missing uranium might now be waiting. Across western and central Iran stretches a mountain chain that few people outside the region had ever heard of before this conflict began. The Zagros Mountains run for nearly 1,500 kilometers, forming one of the largest mountain systems in the Middle East. Their ridges cut through Iran like a natural wall of stone, rising sharply from the desert plains and creating valleys that are difficult to access even in peacetime. For centuries, these mountains have shaped the country's geography, its transportation routes, and even its military strategy. But in the modern era, they may have taken on a completely different role. Because mountains are not only barriers, they are also shields. Deep beneath their rock layers, facilities can be hidden from satellites, protected from airstrikes, and shielded from most conventional weapons. For military planners, the depth of rock above a facility matters enormously. Every weapon has a limit. Even the most powerful bunker buster bombs are constrained by physics. When the United States developed the GBU-57 massive ordnance penetrator, the goal was to create a weapon capable of destroying underground targets that older bombs could not reach. Weighing more than 13,000 kilograms, the bomb is designed to fall at extremely high speed, drilling into the earth before detonating. Under ideal conditions, it can penetrate dozens of meters of soil or rock. That capability made it the most powerful non-nuclear bunker buster weapon ever built. For years, American planners believed this weapon would be sufficient to destroy Iran's deepest nuclear facilities, and in some cases, it was. But the mountains of Iran present a challenge that no bomb can easily solve. Rock density increases with depth. Granite formations become harder the deeper they go. And if a facility is buried far enough underground, the rock above it can absorb the energy of even the strongest explosion. This is why analysts began paying close attention to a site that had appeared in satellite images years before the strikes. A location near Natanz, sometimes referred to by researchers as the Pickaxe Mountain Complex. Unlike many of Iran's earlier nuclear facilities, which were buried tens of meters underground, this site appeared to be carved much deeper into the mountain. Construction activity had been visible for years. Satellite imagery showed roads leading into the mountain, tunnel entrances being expanded, and heavy excavation equipment operating around the site. But because the complex had not yet been publicly declared as a nuclear facility, inspectors had never been allowed inside. That meant analysts had to rely entirely on external evidence. They measured the size of tunnel entrances. They studied the piles of excavated rock outside the site. From those clues, engineers began estimating how deep the internal chambers might be. Some estimates suggested depths of 80 to 100 meters beneath the surface. Other calculations suggested even deeper levels. If those estimates were correct, the facility would be buried far beyond the penetration capability of conventional bunker buster bombs. And that realization changed the strategic equation completely. Because if Iran had moved its enriched uranium into a facility that deep, then destroying it from the air might no longer be possible. The problem is not only about depth, it is also about uncertainty. When a bomb hits a known target, military planners can calculate where the explosion will occur, but when the exact location of an underground chamber is unknown, the challenge becomes much harder. A strike might collapse tunnels near the entrance without damaging the deeper sections where sensitive material is stored, and once those tunnels collapse, reaching the facility becomes even more difficult. From a military perspective, this creates a paradox. The deeper a facility is buried, the safer it becomes from airstrikes, but the harder it also becomes to verify what is inside. By early 2026, analysts studying satellite imagery noticed something else. Construction at the mountain site had not stopped after the bombing campaign. In fact, it appeared to have accelerated. New access roads were visible. Security perimeters around the mountain expanded, and excavation activity suggested that tunnels might be extending even deeper into the rock. This raised an uncomfortable question inside policy circles. Had Iran anticipated exactly this scenario? Had it built a facility specifically designed to survive the very weapons that were supposed to destroy its nuclear program? If the missing uranium had indeed been moved into the mountain, the implications were serious. Because once nuclear material disappears into a facility that deep, it becomes extremely difficult for outside powers to control what happens next. Airstrikes may no longer work. Satellite surveillance cannot see through rock. And without inspectors on the ground, verifying the presence of nuclear material becomes nearly impossible, which leaves only one remaining option. An option that military planners generally try to avoid whenever possible: a ground operation. Because if the uranium is truly inside the mountain, then the only way to reach it may be to go inside the mountain as well. When military historians look back at wars, they often focus on battles, weapons, and political decisions. But sometimes the most important lessons are much simpler. They come from limits of technology, limits of intelligence, and sometimes limits of power itself. The situation surrounding Iran's missing uranium has forced governments around the world to confront exactly that kind of limit. Because for decades, modern military strategy has been built around a basic assumption. If a target can be found, it can be destroyed. The United States demonstrated this principle repeatedly over the last 30 years. Precision-guided weapons destroyed command centers, radar stations, and military bases with extraordinary accuracy. Air power became one of the most dominant tools of modern warfare. But the events surrounding Iran's nuclear infrastructure have introduced a complication to that assumption. Some targets can be hidden deeper than bombs can reach, and once that happens, the balance between offense and defense begins to change. Military analysts studying the Iranian case have pointed out that the real story may not be about the bombing campaign itself. The real story may be about what happened before the bombs fell. Iran appears to have understood something very important. Facilities can be destroyed, equipment can be replaced, but enriched uranium is the most valuable and difficult component of a nuclear program. Protect the material, and the program can be rebuilt. Lose the material, and rebuilding becomes far harder. By moving the uranium before the strikes, Iran may have protected the most important element of its nuclear capability. This strategy reflects a broader pattern in military planning. Throughout history, countries have tried to move their most valuable assets beyond the reach of their adversaries. During the Cold War, both the United States and the Soviet Union buried missile silos underground and dispersed nuclear weapons across vast territories. China built large networks of underground tunnels to store strategic weapons. North Korea placed military infrastructure deep inside mountains. These decisions were not simply about hiding, they were about surviving an attack. What makes the Iranian case particularly significant is how visible the lesson has become. Around the world, military planners are studying what happened. If a nuclear program can survive a major bombing campaign simply by relocating its material underground, then other countries may begin adopting similar strategies. That possibility worries many experts. Because once nuclear infrastructure becomes deeply buried and widely dispersed, controlling nuclear proliferation becomes much harder. Inspectors may not have access, satellite imagery may reveal very little, and political pressure alone may not be enough to prevent further development. The Iranian case has also created a difficult strategic dilemma for the United States. Destroying facilities from the air is one type of military operation, but physically securing nuclear material is something entirely different. To secure uranium stored deep inside a mountain, forces would likely need to enter the facility itself. That means boots on the ground, specialized units trained for hazardous environments, and operations conducted inside a country with a population of nearly 90 million people. Such an operation would carry enormous risks. It could escalate into a broader regional conflict. It could expose troops to dangerous environments, including potential radiation hazards. And even if the facility were successfully captured, verifying and removing nuclear material would be a complex technical process. For this reason, many policymakers believe the situation may ultimately return to diplomacy. Negotiations, inspections, and international agreements have long been tools used to manage nuclear programs. They are imperfect tools. But in situations where military options become limited, they sometimes become the only tools available. Meanwhile, the geopolitical consequences of the crisis are already spreading beyond Iran itself. Energy markets have reacted to instability in the region. Shipping routes near the Strait of Hormuz, one of the world's most important oil transit corridors, have faced disruptions. Countries across the Middle East are watching carefully, trying to understand what the future balance of power may look like. And outside the region, other major powers are also paying attention, because the lesson of the mountain may extend far beyond Iran. If strategic assets are buried deep enough, even the strongest military power in the world may struggle to reach them. That idea is now being studied by defense planners from Asia to Europe. Some countries may begin building deeper underground facilities. Others may rethink how nuclear material is stored and protected. In this way, the missing uranium has become more than just an intelligence mystery. It has become a case study in the future of modern warfare. A reminder that technological superiority does not remove every obstacle. Sometimes the obstacle is simply rock and distance, and sometimes the most powerful weapon in the world cannot change what lies hidden beneath a mountain, which means that the story that began with a bombing campaign may ultimately end somewhere else entirely, not in the sky, but deep underground.